stage, we're going to add a player to the map, control them with the mouse and keyboard, and handle collisions. Let's add a line to the map file to describe the player. Then let's adjust the game class to load that player in. Since we've now got two major pieces of data, the map and the player, it might not make a lot of sense to return the game map. It might make a little more sense to initialize that as a class variable. Let's store the player data in the renderer class. The player can be drawn as a small white rectangle. You may notice that so far we haven't touched any player movement. Before we look at that, we'll need to learn how to rotate points around the origin. Here's the formula for rotating a point around the origin by a given angle. Pretty confusing, right? I remember as a kid excitedly printing out source code for a fairly DIY 3D engine only to stare at this formula in a daze. The problem with equations like this is they're easy to share around without linking to the original concept which produced or explained them. Let's learn about where this formula comes from. A general transformation of a point is a formula which consumes some original data and produces some new data. The most general possible description is simply a combination of all available data. If you're familiar with linear algebra, this can be written as a matrix vector multiplication. And if you're not familiar with linear algebra, get on that. No excuses. Combinations of certain coefficients can describe rotation, scale, or skew transformations. The big question is, given a transformation, how do we determine the coefficients? The answer is surprisingly elegant. We analyze what happens to the standard basis vectors. Why is this? Well, let's say that an unknown matrix T maps the basis vectors to some known new vectors. Then if we write out that transformation matrix, we have and so the transformation matrix can be formed by concatenating the images of the basis vectors I and j. The same principle applies to higher dimensions. Let's look at the basis vectors under rotation. We'll start with I. Here we can see that I undergoes the mapping from 1, 0 to cos theta, sine theta. Now investigating J gives us the mapping from 1, 0 to negative sine theta, cosine theta. And hence the images of the basis vectors give us the rotation transform. Pretty good. This is the transformation matrix which produces the formula we saw earlier. Now if we imagine our player sitting in the world with no rotation, they would look something like this. This is our frame of reference. We will want to compute the player's actual forwards and right vectors by rotating this original data according to the player's angle. But that's enough theory for now. Let's get back to coding. Let's add an angle to our player specification. Now, in addition to position, let's store the player angle. We're bundling all the data together here rather than making a player class. This is a personal choice. I like classes for high-level control, but find them unnecessary for simple data storage. Now let's write a function to draw lines. First, we find the horizontal and vertical components of the line segment. Whichever component has a greater size is considered the dominant component. This will be used for stepping along and drawing the line segment so that points aren't skipped. We then get the increment for each direction by attenuating by the dominant step size. Dividing by the dominant step size ensures that both increments are less than or equal to 1, so points don't get skipped. And then we start stepping. We start at the x1, y1 position and use the increments to step forwards towards x2, y2. This isn't the most general optimal line drawing function, but the session is already going to get quite long and these lines are just for debugging anyway. So now let's draw the forwards and right vectors. This will need to occur after the grid lines have been drawn, because currently those grid lines would go directly on top of the vectors. So here we can see our forwards vector, and looks like it's working just like the diagram. Let's go ahead and put in the right vector. And so here we've got our right vector. Now note that this is reversed compared to the diagram, but this is because of Pygame's coordinate convention. So this is higher y values down here, lower y values down here. So just as in the diagram, the right vector is pointing in the negative y direction. Okay, so this is pretty good. We've got our frame of reference, but the player actually has some rotation, so let's take that into account. In order to do that, the first thing we'll need to implement that rotation angle that we discussed. Rotation function, sorry. Now we can use that rotation function to compute the player's forwards and right vectors. Let's go ahead and do that in the update. And then here we can see that everything's been spun around by 60 degrees. So we have our forwards vector and our right vector. Okay, that's looking good. We're almost done for today, but wouldn't it be nice to add keyboard and mouse controls? First of all, let's take that rotation function and move it to the config file so that multiple modules can use it. Now let's write a function to handle the current state of key presses. The idea is to add or subtract the forwards and right vectors based on which keys are currently pressed. This function can then be called every frame. So the most important thing to check here is that the key movement matches up with the vectors. I can see that my forwards vector is coming out here, and so if I hit W, I want to be moving towards that direction, and if I hit S, I want to be moving backwards relative to the forwards vector. Likewise, my right vector is out here. Now the D key is on my right. So when I hit D, I want to be moving this way. Good. And when I hit A, I want to be moving this way. So even though Pygame's coordinate system makes it look a little bit weird, top down, we can correct for that. But what I'm really concerned about is that the movement matches the world vectors. Okay, so this is pretty good, more or less works, but there are some issues. The first one is the movement speed. So you saw that before we had that parameter, speed, and we could adjust that to sort of change the movement speed, but hard coding it isn't the way to go, really. It would be better to adjust movement speed based on the time interval between updates. Luckily, our game is already calculating its frame rate. We can use this to find the frame time This 1.0 here is just to save us from division by 0. For a game running at 60 frames per second, about 16 2/3 milliseconds pass per update. This can be used to give a correction factor, so faster updates with lower durations will not change the position by as much. This then gives us pretty smooth movement. Okay, so the other issue is, as you can see, we can walk through walls. So let's do collision checking. We'll solve this with a look ahead update. Before moving, we test to see if that move is possible. First, let's check if the position on the map is free. We can then use the key state to set the net velocity before testing. By testing each component of velocity individually, we can let the player slide along walls. This is pretty good. But as you can see, the player is just getting a little close to the wall, so we can adjust this to make sure that we're looking a little further ahead than we're actually moving. So here, velocity x and y is how far we're actually going to move, but we're essentially Euclidean normalizing them and then setting them to a fixed length of 0.25. So that's our look ahead distance. We can go ahead and run this. And as you can see, we can get pretty close to the wall, but not, I mean, we still get pretty close to the wall, but we're not exactly going inside it. So I'm happy with that. To mouse controls. The basic idea of mouse movement is to track how far the mouse has moved each frame. There are a few ways to do this, but my favorite is to continually fix the mouse to the center of the screen. First up, if we've got a mouse fixed at the center of the screen, that's sort of annoying, so let's tell Pygame not to display the mouse. But then if the mouse is invisible, we can no longer X out of the window to close it. And so what I'll do instead is we'll hit escape. It'll be a key press. And finally, we can write a mouse handling function. We measure the mouse's displacement from the center of the screen. Pygame reports mouse coordinates as integers, so we'll only reset the mouse if a movement has been detected. This is important because in reality the mouse can move fractions of a pixel, and resetting every frame will stop it from actually registering any movement at all. So there we have it. If the mouse has moved at least a full pixel, we update the player's direction, including some bounds checking just to keep it in the range 0 to 360, and then reset the cursor to the center of the screen. And that's it. So here we can, oh, of course, we're going to have to call that function. That's fine. And here you see we can move around. And the most important thing, again, this looks a little messed up, but I'm just thinking when I move my mouse to the right, the player's forwards vector rotates in the direction towards where its right vector was. and likewise. The forwards vector updates. And yeah, there we have it. So this is a pretty long session, but we finally have a good foundation to work with. Over the next 2 sessions, we'll look at the raycasting algorithm. Hope to see you there. Bye. Hi, so I just wanted to take a second to say thank you to all of my channel supporters. If you would like to support the channel, it's $2.50 a month. That's all I ask, but it's not expected. If you are not able or willing to support the channel financially, the best thing you can do is the usual: like, comment, subscribe. Let me know what you'd like to see. Let me know what you're enjoying, because I am trying to make the best educational content that I can under the constraints. So with that out of the way, really big thank you to Antonin Carret, Dankil Foles, Declan, Endelon Studios, Isaiah Meyer, Mathieu Derick, Moim, and Shreya. Thank you so much, my dudes. I really do appreciate it. It's fuel for the fire. Keep me going, keep me motivated. But yeah, have a great one, and I'll see you again soon. Bye.